Hey everyone, I am coming on here to do a quick video on the sum and difference formulas in our trig unit. At the top, I want you to notice I have all the formulas already written out. We're not going to derive them on this video. There's some great stuff on the internet, and if you want to check out our calendar, we have a link for a good one on there if you're interested. But here are the formulas. They give us the ability to find the exact value for a sine or cosine of an angle that maybe can be written as the sum or difference of two other angles. And so we have sine, cosine, and tangent formulas. We're not going to really emphasize the tangent ones, but I wanted you to see what they look like. But we're going to focus on just your initial ability to use the sine and cosine addition and subtraction formulas. Our first set of examples, you'll notice I wrote out already here, where these formulas allow us to find the exact value of angles that are not necessarily on our unit circle. So we already know the sines and cosines for things like pi over 4 or pi over 6. But if I gave you something like pi over 12, that's not necessarily on the unit circle, but these formulas do allow us to kind of get an exact value as long as we can write the angle as a sum or difference of angles that we do know are on the unit circle. So before I do my first two examples on that, I kind of redrew sort of our main first quadrant, maybe a little bit into second quadrant, angles on the unit circle that we know. And the key with a lot of these, you'll notice that the examples, if you look at my two here, they have 12 as a denominator because oftentimes when you add our common angles on the unit circle, the common denominator is going to be 12. So our goal is to be able to write these angles as a sum or difference of other angles that we know. Well, what I'm going to do is for each of these angles, I'm going to convert them to angles with a denominator of 12 so that then it's easier for us to look at these and say, all right, which two can I combine in some way to get that? So if I convert pi over 6 to something over 12, I just have to multiply by 2. So this is 2 pi over 12. Pi over 4 is going to be 3 pi over 12. And then pi over 3, I multiply by 4, so that's going to be 4 pi over 12. Sorry, my marker's a little thick there. Pi over 2 is going to be multiplying by 6, so this is going to be 6 pi over 12. I'm going to leave it at that for right now, and then we'll see if we need any others in the future. But if we look at example 1, we're asked to find the sine of 7 pi over 12. Well, if we think about our formulas, we have sine formulas. If we can add two angles or subtract two angles to get us 7 pi over 12, we can then use those two common angles, A and B, and put them into this formula. So if I look at 7 pi over 12, and I'm going to look at all of these combinations with 12 as the denominator, I need two of them to add or subtract to 7. If you want to take a second, pause the video if you need to, see if you can come up with the right combo. If you've tried already or you're waiting for me to do it, I am looking at these and I'm realizing that 4 pi over 12 and 3 pi over 12, those two would add to 7 pi over 12. So how I'm going to rewrite this is I'm going to say that this is the same thing as sine of 4 pi over 12 plus 3 pi over 12. So that's my first step, is to realize how I can split that up. Now, in terms of getting our values from our unit circle, because we know that so well, we probably want to convert these back to the angles that we know and recognize. So I'm going to write that on my next line here. So that's going to be sine, this is pi over 3, which we know a lot about. And then this one is pi over 4. All right. Now what I'm ready to do is I'm ready to use my formula, which is the very top one here. It's the sine of two angles added. So this very first formula is what I'm going to use. Notice that it is the sine of the first times the cosine of the second. And then you add sort of the other combo, the cosine and the sine. I always kind of make note that when I look at the sine, sum, and difference, the sine formulas have the sine and cosines mixed, but the sines actually match what you started with. If you look down here, just as a little side note, the cosine actually have them together, but the sines then are opposite. That being said, we do typically give you these formulas. You don't have to memorize them, but if you know them, it really does make it quicker. Okay, so this is my starting point. That is the same as 7 pi over 12. Now I'm going to go ahead and just use my formula and just write it directly in terms of pi over 3s and pi over 4s. So my first part is the sine of the first. So that is sine of pi over 3. Then it's times the cosine of my other angle, pi over 4. Then the formula does have an addition, so I'm going to add to that the cosine of my first angle, which is pi over 3, and then it's times the sine of my second, pi over 4. Okay, hopefully you guys can see that. All right, now it's just a matter of using that unit circle knowledge. We've got to figure out what those values are. Let's go ahead and come to green here. So the sine of pi over 3, it goes back to our unit circle. Let me go ahead and draw those angles real quick. So pi over 3, I'm going to just draw the ordered pair really quick from my unit circle. Pi over 3 is going to be the one that starts with 1/2 and then ends with root 3 over 2. And then my pi over 4, I'm going to write this angle too. If it helps, go ahead and write it on the side. Otherwise, if you know your unit circle really well, you can just pull it from your head. Okay, sine of pi over 3, sine is going to be the y coordinate, so that is root 3 over 2 times cosine of pi over 4, that's the x, and that's root 2 over 2. That's multiplied together, and then I'm going to add the cosine of pi over 3, that's going to be the first coordinate, so that's 1/2, times, and then sine is again root 2 over 2. The sine and the cosine for pi over 4 are the same. Now, in terms of cleaning it up, this is how we usually want you to kind of clean it up and write your final answer. We're going to clean this up as root 6 over 4, because we're going to multiply, plus, and then this is root 2 over 4. Now, hopefully, you're not going to tell me that this is supposed to be root 8. That is not root 8, but we do like to write this as one fraction. So I'm going to write root 6 plus root 2 all over 4. And that's going to be my final answer. Okay, so again, this is just allowing us to be able to write the exact value of this trig ratio or the trig function without having to grab our calculator, and we just do it in terms of our angles from a unit circle that we know really well. Okay, let's try another example. I definitely suggest if you want to try this on your own, you can, let me find something here to cover that up. I don't have anything to cover that up. Maybe I'll cover it up with this, just so we're not distracted. There we go. Try this one if you want to pause the video. Otherwise, I'm going to walk through this one and show you guys a cosine example. So this one, cosine of 11 pi over 12. Again, I need to look at my unit circle. Let me move this down just so we can see that. I need a combo of angles that add or subtract to 11 pi over 12. So here is where I might want to actually add a little bit more to my unit circle, because none of these, even if I add them, I can't get up to 11. I can actually get up to 10, but nothing is going to combine to be 11. So maybe if I keep going, if I do 2 pi over 3, let's see what that gives me. 2 pi over 3, if I multiply by 4, it's going to give me 8 pi over 12. Let's do one more too. This one is going to be 9 pi over 12. All right, so it gives us a little bit more options. Now again, if I'm going for 11 pi over 12, I actually see two ways I can do that. I can either do 8 plus 3. I can do the 8 pi over 12 plus 3 pi over 12. Or I can shift it over one more and I can do 9 pi over 12 plus 2 pi over 12. Either of those would work. You will find that you'll get the same answer either way. For this sake, I'm going to go ahead and just choose 9 pi over 12 and 2 pi over 12, but it does not matter. You can do the other. Let's go ahead and go start with green, I guess. Okay, so the first thing I'm going to say is that this is the same thing as cosine of 9 pi over 12 plus 2 pi over 12. That's my initial breakdown. Okay, now I'm going to actually rewrite that in terms of the angle we would recognize on a unit circle. So that is going to be cosine of, and this is going to be, let's see, 3 pi over 4 plus, and then this one is going to be pi over 6. Okay, all right, so now I'm just going to throw it into my formula. We are dealing with cosine this time, and it is another addition. So if you look back here to our formulas, the cosine addition, it starts with 2 cosines and ends with 2 sines, but the sign is opposite. So this time we're going to be subtracting. Okay, so it is cosine of my first, which is 3 pi over 4, cosine of pi over 6. Notice we're doing both cosines first. Then my sign is opposite, and I'm going to do the sine of 3 pi over 4 times the sine of pi over 6. Okay. All right. From there, we're going to actually use our unit circle, and we will go ahead and get some values for that. So let's see. I'm going to come over here and scoot it over just a little bit. Cosine of 3 pi over 4. If you think about 3 pi over 4, it's that 45-degree increment. The cosine is negative, but the sine is positive. I can go ahead and rewrite it over here if it helps. The 3 pi over 4 is going to be negative root 2 over 2 and positive. And then my pi over 6 is going to be the one that starts with root 3 over 2 and ends with 1/2. I'll rewrite it there just so we can use that as we fill it in. Cosine of 3 pi over 4, x coordinate, that's going to be negative root 2 over 2 times the cosine of pi over 6, which is root 3 over 2. Okay, and then we are subtracting. Sine of 3 pi over 4 is the y coordinate, so that is root 2 over 2 times the sine of pi over 6 is the 1/2. Okay, so what we have here, oops, I'm getting too close to the bottom there. Let's go back to green. This is going to be, let's see, negative root 6 over 4. And then this is minus root 2 over 4. So we can write that as one fraction. We can write it as negative root 6 minus root 2 all over 4. And that's our final answer. Okay. Hopefully that helps and gives you an idea of what we're doing. If we want to rewrite an angle in terms of ones we know on a unit circle, we can do that. The big key on noticing that is you'll notice that 12 is pretty much our denominator because that's how we can combine any angles on the unit circle. Okay, our last little bit here is just one last example that's a little different. This is not angles that we're going to write to combine from the unit circle, but if we are given information to create two angles with triangles, then we can actually do a similar thing and use formulas. So let me scoot this up. The formulas are no longer in view, but you can hopefully look at them on your notes. I will just use them from memory. Okay, so this example starts by giving us two angles, alpha and beta. We're using those the Greek letters. Angle alpha has a sine that we know is given, and then the angle beta has a cosine that we know. It does clarify, because this isn't enough info. We have two quadrants where the sine is positive, and we also have two different quadrants where the cosine is positive. But they do tell us that both of these are in quadrant 1. So our first goal is going to be to rewrite these angles as a triangle, to create them. So I'm going to do sine of alpha. I'm going to do alpha over here in pink. It is in quadrant 1. Make sure you're drawing your triangles in coordinate space. Even if you know everything's positive, you do not want to just draw a generic triangle in the middle of space. All right, so my sine is 3 over 5, so that's my opposite over hypotenuse. I'm hoping you recognize this one as a nice Pythagorean triple. My third side, I don't even need Pythagorean theorem. I can hopefully know that that is going to be a 4. Okay, so this is my info for angle alpha. If there's any trig ratio I need, I can get it from that triangle. Okay, and my beta, let's do beta in blue, because B stands for blue. Beta, we know that the cosine is 2/3. Again, it's in quadrant 1, so I'm going to draw an angle in quadrant 1. And my cosine is adjacent over hypotenuse, so that's my 2 over 3. This one you would need to do Pythagorean. I'm going to go ahead and kind of skip the steps in terms of writing that out, but I know it's going to be a 9 minus 4 and then square root that. So this is going to be a square root of 5. Many of you might be able to do that in your head as well, but that's Pythagorean theorem to get that. Okay, now that we have triangles for these two angles, we can actually tackle the two problems that we're going to be looking at here. We want to find whatever the sine is of the angle that's made by subtracting alpha minus beta, and then that same angle, we're going to find the cosine of that as well. So I'm going to do the sine of alpha minus beta first. And again, I'm using my formula. I'm going to write out the formula first before I start plugging in values, just so I know what I'm plugging in where. This is going to be sine of alpha, cosine of beta. The signs match, so this is a minus. And then it's switched, the cosine of the first and the sine of the second. Okay, now I just use my triangles and I fill in the values that I need to. The sine of alpha is going to be 3 over 5. It happens to be what they gave us. And the cosine of beta is also the one that they gave us. That is the 2/3. Then we subtract. Cosine of alpha now is 4/5 if I do my adjacent over hypotenuse. And my sine of beta is going to be root 5 over 3. Root 5 over 3. So if I clean this up, I'm going to get 6 over 15 and this is 4 root 5 over 15. I'm going to go ahead and just write it on one line since I'm losing space here. I'm going to write that as one fraction as 6 minus 4 root 5, and they're both over 15, so we can just combine them as is. Okay? All right. The last one will be similar. Go ahead and I encourage you to pause the video, give it a try on your own, and then you can check it before I jump into it. But let's, oh, I'm sorry, we're not doing sine, we're doing cosine. Dang it. I thought I was going to go mistake-free on this one. Cosine of alpha minus beta. Okay, let's start with the formula. It is going to be the two cosines first. So cosine of alpha, cosine of beta. This time, we're doing subtraction. The cosine formula is opposite sign, so it's going to be plus. And then both signs, sine of alpha, sine of beta. Using my triangles again, I'm going to pull my values. Cosine of alpha is going to be 4/5 times cosine of beta is 2/3. That's my first part. And this time I'm adding. And then I have sine of alpha. That's opposite over hypotenuse, so that is 3/5. Sine of beta is root 5 over 3. So if I simplify and combine that to be one fraction, I'm going to have 8 plus 3 root 5 all over 15. All right. And that, ladies and gentlemen, is just a little bit of a taste on how we can use these new formulas, the sum and difference formulas, to be able to kind of rewrite things and still be able to stay within exact form. Hope this helps. Let us know if you have any questions. Have a good day.